welcome back. So in our last couple of explainers, we did two really important things, right? We got connected to our data and we laid down the rules for what that data should look like. But here's the thing, they've kind of been living in separate worlds. Well, today, those two worlds are about to collide. This is it. This is the moment of truth where we actually test our data against our expectations. Let's dive in and see what happens. Okay, so here's our game plan. First up, we're going to talk about something called the data quality contract. It's like the formal handshake between your data and your rules. Then we'll actually forge that contract with some code and run the validation. After that, the fun part, decoding the results. And finally, we'll get into why the real magic happens when you look beyond just a simple pass or fail. All right, let's get right to the heart of the problem. We've got a batch definition, which knows all about our data, and we've got an expectation suite, which holds all of our rules. But right now, they're just two separate things chilling in our project. They don't even know the other one exists. You can almost picture it, right? Our data is over here on one island, and our rules are way over there on another island. There's this big gap in between. We need some way to build a bridge, to explicitly tell Great Expectations, hey, take this specific data and check it against these specific rules. We basically need a matchmaker. And that matchmaker has a name, the validation definition. Seriously, just think of it as a formal contract. It's a really simple but absolutely crucial little object that links your expectation suite to your batch definition. It creates this reusable reference that says, plain and simple, this data must follow these rules. And that is how we build the bridge across that gap. So, how do we actually go about creating this contract? All right, enough talk. Let's get our hands dirty and look at the Python code. You'll be surprised at how straightforward it is. It really boils down to a super simple three-step process. First, we just grab the components we've already made, the data definition and the rules. Second, we define the validation itself, creating that link. And third, we just add it to our data context so we can use it over and over again. Now, the main thing to notice here is that we aren't creating anything brand new. We're just pulling in the components we've already built. We're using our data context to go and fetch our expectation suite by name and then grab the specific batch definition we want to test. It's kind of like gathering your ingredients before you start cooking. Okay, once we've got our ingredients, we just instantiate the validation definition. This is the moment where we formally link our data and our suite, and we give this new contract a unique name so we can find it later. Finally, we add it to our context, which saves it to the project, making it ready to use whenever we want. All right, the contract is signed and saved. Now for the really exciting part, actually executing it. This is where we run our data quality tests and finally see what we've got. And check this out. All that setup, all that configuration, and it all comes down to this one beautiful, simple line of code. Validation definition.run. That's it. This kicks off an on-demand run, which is absolutely perfect for when you're developing, testing things out in a notebook, or just exploring. When you run this, Great Expectations gets to work and hands you back a super detailed results object. Now, running the validation is the easy part, but what comes back? Well, it can look a little intimidating at first glance. The validation result object is just packed with information. So let's break down this report card and make it simple to understand. So when you get these results back, what are you actually looking at? Let's pop the hood and take a quick guided tour of the most important pieces of information inside. At the highest level, you're looking for three main things. First, there's the success key. It's a simple true or false. Did everything pass? Easy. Then you've got the result key. This is a dictionary that holds all the nitty-gritty details for every single expectation you ran. And finally, there's exception info, which is your best friend for debugging if the code itself crashed for some reason. Okay, now let's zoom in a bit into the result dictionary for just one of our expectations. This is where you get incredibly useful stuff. Unexpected count tells you the exact number of values that failed. Observed value shows you what your data actually looked like, and my personal favorite, partial unexpected list, gives you a sample of the actual bad data. I mean, for debugging, that is pure gold. And here's the most important takeaway from all of this. Validation is so much more than a simple pass or fail. As you're about to see, the real power comes from the granularity of the results and the fact that our rules are decoupled from our data. This gives you deep, actionable insights. This happens all the time. Your validation might come back with success false, but that doesn't mean it's a total disaster. It could just mean that, hey, 9 out of your 10 expectations passed perfectly and only one little thing failed. this idea of partial success is really, really key. I absolutely love thinking about it this way. A validation failure isn't just an error message. It's a map. It's a detailed report that pinpoints exactly where your data quality has sprung a leak, which empowers you to go find the source of the problem and actually fix it. And this is what that map looks like in the real world. So here, our expectation that fair amounts should be non-negative, well, it failed. But the results tell us exactly why. There were 14 unexpected values, and the partial unexpected list shows us a sample of what they were. A bunch of negative numbers. Boom, we found the leak. This really shines a light on a core concept: granularity. The results aren't just a thumbs up or thumbs down. They are detailed all the way down to the specific values that failed. And that's the difference between knowing that you have a problem and knowing exactly why you have a problem, which means you can go fix the root cause. The other powerhouse concept here is decoupling. Because our expectation suite is totally separate from our data definition, we can reuse it everywhere. We can write our rules just one time and then point that same suite at a little local CSV file while we're developing, and then turn around and point it at a massive production SQL table. The rules don't change, only the data source does. How cool is that? So there you have it. We went from having two separate things, data and rules, to creating a formal contract that binds them together. We've run validations, and we've learned how to read the super granular results to find the exact source of any problems. We've basically turned data quality from a guessing game into a precise science. So the only question left is, which hidden data quality issue are you going to uncover first?